Okay, so for chapter 9, we want to begin to work through the practice problems. So 9.1, question 1 says construct a confidence interval of the population proportion at the given level of confidence. So we have x to be 80, n to be 200, and at a 99% level of confidence. So what this means is that the sample that we take a sample of 200. Now 80 out of those 200 have a characteristic of interest. So if we use an example of, let's say we take a sample of 200 CMU students, and we are interested in knowing how many of these students have cars, okay, and then we realize that it's 80. Now we want to construct a 99% confidence interval for them. So what do we do? So we want to have an interval to say that, okay, the true proportion of CMU students who have cars will fall within that interval. So to construct the confidence interval, that is, we need to know our point estimate and also our margin of error, so that our point estimate plus or minus the margin of error will give us the confidence interval. Now the point estimate, which is the sample proportion, is giving us P cap, which equals x over n, and that is 80 over 200, and that equals 0.4. So our point estimate equals 0.4. Then we need to know our margin of error, and margin of error is giving us z alpha over 2 times the square root of p cap into bracket 1 minus p cap over n. Now what is alpha? So we can know alpha from our confidence level, and our confidence level is 0.99 or 99%. So 1 minus alpha equals 0.99, and therefore alpha will be 0.01. And then alpha over 2 then will be 0.01 divided by 2, that is 0.005. So putting back that value back as a subscript of z, so from chapter 7.2, we have seen how to find this z value. So when you see z subscript 0.005, it means that you want to locate the z score when the area to its right is 0.005. Or in other words, you want to look for the critical value, okay? And there's a summarized table which I've made available, I showed in the first video, which summarizes what chapter 9.1 entails. Now, so we realize that z 0.005 equals 2.575. Right. So with that done, we can now construct our confidence interval. And mind you, that will be the point estimate plus or minus, so 0.4 plus or minus 2.575. Then square root of, so our p cap is 0.4, 1 minus p cap is 0.6 because 1 minus 0.4, divided by the sample size, which is 200. So you realize that when you subtract the margin of error from 0.4, that gives you 0.311. So that is the lower bound. Then when you add the margin of error to 0.4, that gives you 0.489. That gives you the upper bound. So our confidence interval for P, which is the true population, remember P is the population proportion or the parameter of interest, is that confidence interval is 0.311, 0.489. So that is how we go about the process, from scratch. But what if we want to use technology just to get our results? So using the TI-84, the steps are provided. Look at it, practice it, and get used to it. So it takes you through 4 steps. So you first do your stats, tests, and then in test you search for option A, which is 1 prop z int. So it asks you to enter your x, your n, and then enter the confidence level that you are working with. So the confidence level, you need to enter it in terms of decimal. So in this case, this has to be 0.99. Okay, so our x is 80, our n is 200, our C level is 0.99. So with that entered in the calculator, our calculator gives us the result, and That will be 0.31077 on the left and then 0.78923 on the right. So our confidence interval is given as in the picture. Now, one other thing we need to know is how to interpret this result. So we say that we are 99% confident that the population proportion is between 0.311 and 0.489. Okay, and what does this mean? It means that when we construct 100 intervals, 100 confidence intervals, okay, or 100 intervals, which are coming from 100, taking samples 100 different times, okay, then 99 of those intervals will contain the actual population proportion. Okay, so that is what the 99% confidence interval means. So we are 99% confident that the population proportion is between 0.311 and 0.489. Now question 2. It says determine the point estimate of the population proportion. So that is 1. The margin of error. 2. Then for the following confidence interval, and the number of individuals in the sample with the specified characteristic X for the sample size provided. So we are looking for 3 things: the point estimate, the margin of error, and then the X, the value X. That is the number of people who have a characteristic of interest. Now we are given the lower bound. So in this case, we are given the lower bound, the upper bound, and then the sample size, but we don't know P cap. Okay, so remember, P cap is a value that falls in the middle of the lower bound and the upper bound. Okay, it's in the middle of the interval. So how do we find that? The middle will then be the mean, right? The mean of the interval. So that is 0.581 plus 0.909 divided by 2. So our P cap gives us 0.745. 0.745. Then the next question, our margin of error. Now remember, the margin of error is that value or that distance from the P cap to the upper bound or from the P cap to the lower bound. Okay, so to find the margin of error, we can consider the P cap minus the lower bound or the upper bound minus the P cap. So computing, margin of error will be 0.909 minus 0.745, and that gives us 0.164. So margin of error equals 0.164. Then we want to find X, okay, the number of people that have a characteristic of interest. But we know a formula that contains X, which is P cap equals X over N. And we know P cap now, 0.745, and we know N, 1000. So when we do the algebra, X should be equal to 745. 745 people have a characteristic of interest from the sample. Alright. Now we move on to question 3. It says compute the critical value Z alpha over 2 that corresponds to a 94% level of confidence. Okay, so this question is just asking for the critical value. Now, how do we know alpha in this case? We know that there's a relationship between alpha and the level of confidence. So if level of confidence is 94%, then 1 minus alpha equals 0.94, and doing the algebra, alpha will be equal to 0.06. Then we need to find alpha over 2, which is 0.06 divided by 2. That gives us 0.03. So we are looking for Z alpha over 2, which is a critical value, and that is Z 0.03, Z subscript 0.03. So from chapter 7.2, we can find that Z subscript 0.03 means that we want to find the Z score where the area which has the Z-score which has the area to each right to be 0.03. So using the inv-norm function, right, which is on a TI-84, inv-norm takes the first argument to be the area to the left, then the mean, and then the standard deviation. So area to the left, if the area to the right is 0.03, then the area to the left should be 0.97. So 0.97, the mean, which is 0 because we are dealing with the standard normal, then the standard deviation is 1. So this gives us the result 1.88. So the critical value at 94% level of confidence is 1.88. Question 4. It says, in a poll, 69% of the people polled answered yes to the question, are you in favor of the death penalty for a person convicted of murder? So, the person convicted of murder, those who responded yes, okay, are the people who have a characteristic of interest. And this poll has already identified the proportion of people, okay? So the proportion of people in the sample who have agreed yes, and that is 69%. And then we also told that the margin of error in the poll was 2%, and then the point estimate was made with 95% confidence. At least, how many people were surveyed? Okay, so let's find out what they have given us. So they have given us P cap, which is 69%, and that is 0.69. We are also given the margin of error, E. Okay, that is 0.02 because 2% margin of error. And can we find alpha? Yes, we can. We can know that from the percentage of level of confidence given. So 95% confidence means that alpha equals 0.05. So if alpha is 0.05, then alpha over 2 will be 0.025. And the z-score, or the critical value for that, is 1.96. Okay, you can refer to the summary sheet that I've given, okay, or you can calculate this on your TI-84. So with these values given, let's see if we can determine the number of people that were sampled. So remember, in the confidence interval equation or expression, the side which contains n, because n is what we are looking for, the side which contains n is the equation for margin of error. So margin of error equals the critical value, which is z alpha over 2 times square root of p cap times 1 minus p cap over n. So what we can do here is to do a little algebra, right, and then solve for n. So solving for n gives us n equals p cap times 1 minus p cap times into bracket z alpha over 2 divided by e all squared. Now we know every value that is on the right, so we put them back into the equation, and we realize that approximately n equals 2046, 54.3. Now, one rule that goes with finding the sample, okay, that was taken, the sample size, is that whatever value you find, you want to consider to the next integer. So because we found 2054.3, so the next integer will be 2055. So we would say that about 2055 people were sampled, okay, or were polled to arrive at this particular outcome that was spoken about in question 4. So the answer is 2055 for question 4. Now question 5. It says Katrina wants to estimate the proportion of adults who read at least 10 books last year. To do so, she obtained a simple random sample of 100 adults and constructs a 95% confidence interval. Matthew also wants to estimate the proportion of adults who read at least 10 books last year. He obtains a simple random sample of 400 adults and constructs a 99% confidence interval. assuming both Katrina and Matthew obtained the same point estimate, whose estimate will have the smaller margin of error? Okay, so we realize that Katrina sampled 100 adults and 95% confidence interval. Matthew sampled 400 adults, so more adults, and also has higher confidence interval. So we want to know who will have the smaller margin of error. Okay, so remember some facts that are coming out of the confidence interval for population proportion. And one fact says that as the level of confidence increases, the margin of error also increases. And then also, as the size of the random sample increases, the margin of error decreases. Okay, so what that means is, with this very example, Matthew, when you consider Matthew's sample size, yes, Matthew has more sample size, so his margin of error will decrease, okay, will be smaller. But then, when you also consider he has the higher confidence interval, so with a higher confidence interval, the margin of error should be increasing. But what really happens is, because the sample size is way greater than Katrina's sample size, then there will be a much more significant increase, right? So I have the statement written here. As the level of confidence increases, the margin of error increases. As the sample size increases, the margin of error decreases. But look at this. Matthew's estimate will have the smaller margin of error because the larger sample size more than compensates for the higher level of confidence. So even though Matthew has a higher level of confidence and therefore he should be having the larger margin of error, what happens is his sample size is way higher. So there will be a much more influence coming from the sample size. And you know, a larger sample size results in a smaller margin of error. So the conclusion to this is Matthew's estimate will have the smaller margin of error because the larger sample size more than compensates for the higher level of confidence. Okay. Then finally, for question 6, it reads, a group conducted a poll of 2,058 likely voters just prior an election. Okay, so a group is trying to conduct a poll to see who will win, right? So the result of the survey indicated that candidate A would receive 48% of the popular vote, and candidate B would receive 45% of the popular vote. The margin of error was reported to be 4%. The group reported that the race was too close to call. Use the concept of confidence interval to explain what this means. So, in the poll that they conducted, they didn't do it on everyone who is going to vote. They just took a sample. So it means that the outcomes that they are taking out are just on the sample. So they realized that for candidate A, the sample proportion is 0.48 and the margin of error is 0.04. Okay, so they arrived at these values. And then for candidate B, the sample proportion is 0.45 and then the margin of error is also 0.04. So what we can do is we can draw the confidence interval or the confidence interval for A and B, and what we notice is the confidence interval for A is from 0.44 to 0.52, and then for B is 0.41 to 0.49. So I try to draw these two, their confidence intervals side by side. Then one thing you will notice is their confidence intervals overlap. Now, because there is an overlap, what that means is the actual proportion of votes that A could get could fall between 0.44 and 0.52. And what B could also get can fall between 0.41 and 0.49. What you realize is because there is no distinct difference between these confidence intervals, there is an overlap. It means that it is very possible they could have the same proportion of votes when the election actually takes place, or at one point B could have more proportion and A could have less, or the other way. So that tells you that there is not a clear indication of whom the winner is going to be from just this poll. So because their confidence intervals overlap, the poll cannot predict the winner. So that is how we use the knowledge of confidence interval to arrive at such a decision. Okay, so this is an experiment you can also do. You do it for two people, and you realize because your confidence intervals overlap, you can't have a clear-cut decision. Alright. So if you have any question, reach out to me. My office hours, send me an email, and then I'll gladly help you. Thank you.